Hey, it's been several days since I worked on this. Might as well see if it is holding nitrogen. I had a little bit of a challenge on this one, so I'd kind of repurposed this to be just a 2-circuit evaporator coil. And I was pulling out some of the jumpers, the U-bends, but some of them kind of tore out a little crudely. Or I would have the pliers on them, when they got hot, and they kind of bent real easy. So pretty fragile stuff here. And this one here kind of messed up, so I actually dug into the coil a little bit. It's kind of a shame because this was like a brand new, barely used takeoff that I had sitting for a while that I'd gutted just for the cabinet and for the coil. And then, the coil turns out looking like that. So when the cabinet's on, it's not going to be so bad. This is going to be changed. I just have it on here because it was already connected. So I think everything held. So I'm turning on this. Testo changed the wrap a lot recently. 315. That's what's trapped in between the deal and the valve here. Oh, I gotta open this. The wrench. 321. 323 is what I wrote down. You get a little bit of change for temperature, and it's probably a lot colder in here than it was before. It's probably barely over 60. It is 60. So 60 in there is probably a few degrees above that out here. So I'd say that this is holding because 321.7, 322 basically. I wrote down 323 days ago. It held actually already at like 100 whatever PSI, and then I jumped it up to like that. Yeah, 145 held for a couple days, and then 323. It's actually been close to a week, really. So actually this little mess is holding then, so that's good. So this will be the evaporator. Just used the capillary tube that was actually already on the system I took out, that this compressor came out, 10,000 BTU compressor. So should be about right. This was 18,000 BTU coil, so I'm not using the bottom subcooler circuit. That's just effectively for a condenser. I'm not using the top 2 rows, so I'm actually using a little more tubing and surface area than I need. So, and I'm just using to absorb heat for the heat pump. So it should be all good to go. I'll have to obviously cut and reconnect all this here. But just wanted to hold off there until I realized if the pressure was going to hold. Hey, what is up, guys? Finally getting a little motivation to come out here and continue some work on the water heater heat pump version 2.0. So, been under a pressure test. I think I wrote down 323, and it held for pretty much almost a week, and now it's been days since then. It's even colder today, so pressure probably be down a few PSI, but pretty close. So let's get this Testo app going. Basic view. Oh, there we go. 322. With it being, 40 degrees outside. And probably like 50 in here. 50 something. So, yeah, so it's been holding. So I wanted to make sure there wasn't any leaks after all this, what I did. This has got to come off. I just used it all attached and sealed it up, but I'll be disconnecting this and then bringing it over to the suction line, which is what I'm gonna probably start doing now. So just heard my inverter go nuts in here because I just turned the heat on because it's cold. 57 right here. So yeah, I just went up to almost 2 kilowatts. It's pretty early in the day, so it's only making about 900 watts on the panel, so it's tapping off the batteries now a little bit, though. They'll be making enough solar energy to run the heat in here, especially once it throttles back. Oh, it ain't blowing hot yet because these do that anti-cold blow thing. You always get people asking you about that, thinking something's wrong with them. These ductless units. The fans don't start until the coil gets hot. So usually this starts trickling up as it warms up. So yeah, about 322. So yeah, and I wrote down 323 about 10 days ago. So we are good. That part is not leaking. So I could go ahead and start refabricating this. It's all just hanging there. So the liquid line is just going to connect to this liquid line. I wonder if I should put... I'm almost thinking of putting some ports in there in case, like I did on the other one, in case I want to also connect it later to the high wall in that project area in there, in my little corner high wall I've been using, which is what's being used for the evaporator for my other water heater heat pump. Especially during the summer, might as well reject the heat out of the room that's getting hot. So I'm thinking I might put some ports so I could switch manually between the outdoor coil and indoor coil. And then I got to move these lines so I can get the cabinet around. And I don't know if I get motivated enough, maybe I'll do that all right now. So check it out. Been going through, a lot of copper fit pipe out of ductless and out of the Frederick units that I've taken apart. Good bends here. And this was from Frederick a couple years ago, and they added all this freaking like lead weight pieces on the pipes to keep them from shaking and breaking and everything. But now that I've been around a few years, this stuff is like nasty. It's like touching tar. It gets on everything. Sometimes you don't realize it, and then you touch your clothes. So I've been had to take like carb cleaner and soak a towel just to get that stuff rubbed off. But I want some of these radiuses. Okay, I'm getting ready to do a pressure test, but let's go over something over here. These are my Testo kits. I've got the original manifold in the case, the original one. I've had to do some repairs to the probes on those. That's the wired one. Put new ones in. And then right after I got that, I got this kit here. This and the air probes. And I've used the shite out of these. One thing you want to do, because I've had to fix it, is you want to secure this wire so it's not flapping around. So even when I got a couple new ones of these, and I even secured them like that. But I think this right here is where I fixed it, maybe. Or is that part? No, it's part of it. But I've had to fix these, and I clamped them. And then these, the rubber pops out. I wrap it with tape. I actually preferred it this way because you couldn't accidentally push the button if it was like in your pocket or your tool bag. This one like totally fell and broke eventually, so I kind of held it together like that, and some RTV. So they actually both still work. But I just remembered, or actually found, that I had gotten another set of probes. And you can see these are closer to new condition. Probably only used them a few times. I have them sit up there. Look at the seals. So swapping the batteries into those, link them up. But yeah, and I also have two more. I think I have a whole nother set. I think I might have two more of these too, but I'm not sure. I might be remember wrong. It could be that I had extra of those. Okay. Got the Testos hooked up to my ports in this crazy labyrinth of piping that I got in here. Now, for people who don't watch my channel that much, this is just project, do it yourself on your own equipment, experiments, stuff like that. This isn't anything I would invest time for a customer, or would I just use spare parts generally for a customer. But at home, my whole thing is I'm using recycled stuff. Almost everything I didn't pay for. I just got it from takeoffs, whatever. Stuff people keep giving to me. So got ductless units I've scrapped. I got that Frederick unit, which is what I just took the guts out of to build this, to be a little larger compressor, and it's 240 volts instead of 115. And before I go over to this, for people that haven't been watching, and we have started my basic pressure test there. Show you what I've got already. So for a couple years now, I've been heating my water with a heat pump, and the breaker's turned off to the elements. And I put this in 2019 when the house flooded. So it was like actually it was right after that. So it's actually been longer than I thought. It's been 4 years or so. Because I used to start out with a water source heat pump actually mounted in my garage, and then I built my own little one to heat this. And it's evolved from there. So this is my homemade controller. It says it's in standby. I could read my suction temperature and liquid line temperature from right here. That's why it's just, and then this just has a probe down in the middle of the tank there to turn it on. And then this cycles my pump, which I got better at after a while. Realized, to keep the minimum heat rise and always just hot water coming back, I cycle the pump with the temperature of the liquid line out there, which tracks with the temperature of the water in the coaxial heat exchanger. So, Now the one that's out there, the way I have it hooked up now is this high wall. I just had the fan just running continuous. Circuit board's pulled out of it. And I just have my own little controller up there that's telling this ECM motor what speed to run. So it just runs all the time. That way, whenever this runs, that evaporator's got air blowing through it. Let's go to the outdoor unit. Okay. This equipment, a lot of it's Frankenstein, as we've been calling it. So this is my upstairs heat pump. I just wanted it for the slender cabinet, but it doesn't have the ductless, type compressor or circuit boards in anymore. So my own little three-phase scrolling VFD in there. This is my heat pump for my water heater. Doesn't look like much. It's been used for like 3 years. I think this is the third winter I used it. So this was a wine cooler condenser section, and I just changed the compressor from those little portable coolers, repiped this to be a 2-circuit evaporator coil, and the hot gas just goes into this coaxial heat exchangers back in here. I've messed with it, so this ain't pretty, but it works. And that's just all encapsulated with foam, because I want to hold the heat, and I just wrap this with, to keep the heat in. Since rotary compressors, the whole shell is hot, so I want that heat to go into the water. So it comes out after that heat exchanger comes out from here, and then it goes down. How do I got it? It goes up and it feeds these, splits the 2 circuits. And what I have here is this is leftover from ductless stuff. I have 2 circuits, and I just use them for isolation pump down valves. So right now I'm using that high wall in there. And I just have it going through the liquid line, through a capillary tube right here into that liquid line, and this capillary tube is perfect. And I've been getting like 39-40 degree coil now that it's been down into the 60s in that room in there. And then the suction comes back here. And before I had that hooked up, I was using this one. So when I read another one of the revisions I did was I put this on here so I could switch this. Like in the summer, I would use that coil in there. And I've kept that through the winter too, just because it doesn't freeze up in that room, and there's way more heat load in there from my inverter and everything that's in there. Where this one would like to frost up, and sometimes it would really freeze up, and I'd have to turn it off for a while. I never did add a defrost to it or anything. But all I have to do to run this coil is plug the fan wire in and pump down that circuit and open up this circuit, and it works. I can use either the outdoor evaporator or the indoor one. So that's just how it works. It actually works really good, but this is like a little tiny compressor. It's like barely 6,000 BTUs, maybe. Barely half a ton, maybe. And it's been abused for a while as I kind of developed what I was doing. So this here was a little 18,000 BTU ductless that I acquired. And I gutted it. I didn't have any matching equipment going to it. And actually, I later on figured out that I probably could have just slapped a 1-ton high wall and it probably wouldn't have cared. But anyway, I gutted it. I put my other compressor back up a couple years ago. I put the compressor from that other one on there. But then I piped the gas from here all the way over to that heat exchanger. It just was losing too much heat to be efficient. So I kind of undid that. But that was before I was cycling the water pump, so I probably could have used it. Anyway, since I took apart this 240-volt Frederick little Vertipack, I took this compressor out, and this compressor looks up to be 10,000 BTU. So it's not that much bigger than the one out there, but it is. Well, 6,000 to 10,000, it's a pretty good amount when you're down at that small scale. Plus it's 240, so it'll drive directly off my solar charger inverter that I changed out to a 240, and just should have a little more performance. And I got the heat exchanger right there, which once I know this all works, I'm going to foam that over. So I got to put my little control board up here that's going to run this fan. Probably going to keep this really basic out here and just have a contactor or just a big relay or something to start this compressor, and then another one, or just a auxiliary relay just to tell the fan to start. And that's when you're using the outdoor coil. I repurposed this into just a evaporator coil here. Got to clean that, but this is actually the capillary tube that came out of the Frederick. So it's actually 10,000 BTU. Should be right there. So what I'm doing on this one is I put this back on here as I'm repiping this today, so I can hook up, if I want to, my indoor high wall to this. And other than that, I'll just keep it closed. And so my hot gas that just go through this kind of comes out through this funky thing. That was already a bend, and then I kind of got it going down here. Goes into the heat exchanger. Goes to the coaxial heat exchanger, comes out over here as liquid, you know, or it might have some bubbles just because, you know, depending. But we're just going to use capillary tube. So that just a part I took off something else, so it's already a good splitter. And I split the liquid line, one going this way, which is going to be for this coil. And if I open this one, it's going to go through here, hit the capillary tube, feed the 2 circuits I made, go up, crisscross, go up, come out, suction, hit this T, draw down in the compressor. But if I want to use the indoor one, I'll pump down that, you know, and as I open this one, and that other splitter will feed this way instead, go to the indoor high wall, come back to the suction, up through here, hit the T, back to the compressor. Should work. I mean, it's basically the same thing I've already got. It's just a little bigger and with a different voltage compressor. So, hoping this one works good. Hopefully it looks like something when I put it back together. This was like brand new when I got it. But I mean, I had it stored in the shed out there, and it's just all greasy and everything from stuff sitting on it, and it just got this way, even though it hasn't really been used. It's just crazy. Even this, I think I was outside and then I put it in the shed, but yeah, it's crazy. So right now, I'm just going to keep it on the nitrogen test for a few days. If this is holding, which it's held for since I started making all these clips, I'm going to go ahead and pump it up to like 300 plus like I did last time, and then I'll leave it for maybe another week or something. If that's all good, then I know my refrigerant circuits are all tight. Then I'm going to go ahead and continue on with the water connections, which I got those which came out of a water source heat pump. They were hanging on that coax, and I'm just going to figure out some way. I might either come with them both back here, or I might just bring them both out here and notch. I'll have to see. If I make that too much in a switch, if I cut that in a Swiss cheese too much, it's probably not going to like to go back on correctly. But I already kind of Swiss cheesed this when I had made these ports over here last time for something. Oh, that was where I had the hot gas leaving and coming back. That's why I go into the other coax. But this time I shoehorned it inside. So I think it's going to work pretty good. And it's always fun repurposing and fabricating. And I don't know if it's luck, but so far every time I do that, it seems to work. Like I get good superheat, pressures are great. I converted that AC into a heat pump on the Linux, and I still get comments on that. People asking, you know, wanting to do it, but it's not one of those things, you know, to instruct other people to do, just because it's just a project. But this is show and tell. It's like a lot of my car videos are show and tell, and people get mad because I don't show them like every step by step. But sometimes those videos aren't meant to be like a how-to. But I do get a lot of views from car video clips. Anyway, that's gonna do it. And that isn't a leak. It's just crap. But I think we had oil containers sitting up on here, honestly, from when they've changed oil, which is why it looks like that on top, which probably some of it must have dripped. Then I screwed this bell end up and had to butcher this. I almost gave up on this thing, but then I didn't. And it's holding. We'll see how it works. Before I switch out the other unit, when I get this done, I'll power this up and just run some water through it and do a test. So that should be it for now for a little update. Just for haven't been putting up much HVAC videos. Okay, what is up? It is Thursday night. And I'm going to do a pressure test. I've just left this on here for since the weekend. Just turn the power on. Hoping that it isn't leaking. Basic view. Oh, look at that. And it's even cold still, so it's going to go up a little bit as it warms up. 323 psi. Yeah. It's exactly where I left it. So it is holding. That's awesome. So this mess seems to be good. Even with all this and this flare connection, you always got to worry about these, man, because my concentric whatever flare tool was a cheap Amazon one, not like a $200-300 one. It actually works okay, but I know the smaller size copper kind of not so precise sometimes. But I made a pretty good shoulder on it, got it on there. So I think it's going to hold. So this line here, it's open, and actually is the one that's going to feed the outdoor coil as an evaporator with the dual circuit through the capillary tube. And then this one's closed, this one's closed. So I just have this so in case I ever want to hook up the high wall, which I might want to in the summertime, by next summer maybe, if I get this hooked up by then, hook that up. So I'm taking my time kind of on this. Gotta make sure that's separate. The one that's the 115 volt one I have, 6,000 BTU, is working actually pretty okay. Like I said, it takes a while to recover the heat, hour to an hour and a half or so, if we really run it down. But generally, we never really run out of hot water. So it's heat up to 130, so it's always got good hot water. We do use the showers and baths or whatever. So maybe this weekend, depends what I got going on, come out here and finish the water tubes to kind of get it set up to where this panel could kind of go on and it'll look like something. And then after that, start working on the control for it. Might make it kind of basic, but we'll see. Might use a little microprocessor controller still to run the fan, pulse width modulation to feed the brushless DC controller, the IPM inverter power module that I have that will run these motors. Got the motor kind of done and working. In another video, I had the fan on backwards. Freaking laughable. But that was because I have the short units and then I have the tall unit. On the tall unit, the flat side goes out. Which I went out there and confirmed in a previous video. So when I slapped this on at first just for testing, I wasn't paying attention. I'm like, wow, this concave looks like it's like this instead of like this. And that's odd. And it was turning the right way, but it just, obviously the blade was flipped around. So we got that on there right. This is a single phase 230 volt compressor, so I got that ready to go. So I'll need to put the capacitor in there. This is the actual capacitor and bracket that came off the unit. I took it out of it. It was a running unit. So I got to mount that in there somewhere, and I'll probably put the IPM up here and then my little basic controls up there to stage the pump and all that stuff based on liquid line temperature. I'll have to think of where I'm going to put that. And I'll have to put it probably right about here. Maybe I'll weld on a little well for it. Because that's how I like to control it, which works really good. It, basing the pump on and off and then the speed of the pump for the circulated pump to the water heater based on liquid line has been working pretty good for me on the other unit, which always basically like regulates the output of the water temperature to always be like usually shoots out at least 130 degree water into the top of the tank, so comes out pretty good. So anyway, yeah, so it's rock steady there. So happy with that. All this monkeying around with the refrigerant lines, and wow, I only had to go. Found one spot I didn't solder all the way around and had to fix, and that was it. I mean, for this freaking Frankenstein shit, it's pretty good, though. All that's put together, and I only had to fix one thing, and that's been holding for almost a week since the last phase. That's awesome. So should be good to go on the reefer side. We can get on the water side in a couple days, maybe. So see how everything goes. Anyway, with that, don't forget to like, share, subscribe, and comment.